Yep, let's start. Let's talk about background services today. In particular, let's check what's available in the modern browsers related to these interesting features. And also, let's think a bit about how to use these services for delighting our customers, for keeping them safe, secure, and delivering some extra interesting features. My name is Maxim Salnikov. I'm super happy to be a guest of your great community tonight. I do developer relations in Microsoft, and I'm big fan of web and PWA and developer communities. I run a bunch of meetups in Oslo, where I live, and I run 2 full-scale conferences. Maybe you heard about some of them, NG Vikings, Mobile Era. Also, back to PWA topic, I'm organizer of PWA Conf. We planned to have it that April, but because of obvious reasons, we have to reschedule. So stay tuned. This will happen, most likely online, quite soon. How to stay connected? This is my Twitter, webmaxru, and this is actually the best place where you can reach me out for anything. Ask your questions about PWA, about service workers, about cloud, about communities. I'm super open for meeting you there for all the discussions. And I tweet mainly about web technologies, about progressive web apps, and latest and greatest features of the web platform. Back to today's topic. Let's imagine that we as developers, as web front-end developers, to be precise, have possibilities, interesting ones. For example, we have a chance to keep our application itself and the data it consumes from different APIs, CDNs, always fresh. Let's imagine that we have a possibility to schedule some notifications for our dear users, customers, clients, visitors, you name them, of our application, regardless of their connection status at the moment of notification itself. Also, let's imagine that we have resilient downloads and uploads, and that we don't have to suffer so much because of, for example, connection is going up and down. So we make sure that the download will continue. And furthermore, it's even more interesting. We can do everything without asking anything from the user side. I mean, we don't have to ask our users to reopen the browser, reopen the tab with our application, to click this or that button. No, everything is happening automatically. For me, that sounds really cool, and it really brings web to the next level. So what is a background service? This is the feature, the part of functionality of the modern browsers, many of them, which is helping us developers to run a code, obviously JavaScript code, on the user device with some interesting specifics. Let's list some of them. First, this code, which is part of background service, will run in a different thread compared to the main one. So we will not slow down UI, the interactions. So that's always good. But here you can say, well, we have absolutely same feature in great functionality called web workers. Yes, you are right. But I have more differences. This code will have completely separate, detached lifecycle. I mean, once it's registered against the origin, or I don't know, sometimes we can replace term origin by host to simplify it a bit. It's not that, like, let's say, super correct term in that sense, but let's simplify like this. So once we registered this piece of code against the host, done. We can close the application tab, we can close the visible part of the browser. The code will work when needed. But when needed, the code starts at particular events. I mean, if we start main JavaScript thread as a reaction on user opened the tab or clicked some button, in that case, we start this code, we invoke this code by sending particular event to the place where it runs. It can be we who send this event, for example, from the backend, or it might be some operating system event or browser event. We'll have a bit more closer look to this on the next slides. So looking at these 3 points, I have analogy in mind that this piece of code is sort of phantom, ghost. What I mean, our application is dead, for example, when we close the application tab, but pieces of our application and the code we write as a part of background service, it's of course part of our overall application. So this code is running here and there from time to time, regardless of the main application, and lives its own life. Quite short though. So that makes this code sort of phantom, and that makes the browser sort of a haunted house or house with ghosts. Let's talk about event types. So once we mentioned that this code invoked by events, let's give a proper shout out to different types of the ones. First, it's related to connected or disconnected state. And in particular, we can get event on the fact when we go from offline state to online state. That's an interesting possibility. We'll talk about this a bit later. Next, we always do some network operations, right? We fetch some data, we maybe upload some data, and we can catch corresponding events in our code, which is part of background service. For example, the download was successful or unsuccessful. Also, we can track progress. Some events can be based on timings and in very different manners. We'll dedicate some slides to this particular scenario. And of course, we can send this signal or event, to be more precise, to this code, which is residing on the machines of our clients straight from our backend. Of course, in that case, we have to be connected, or not we. By saying we, mainly I mean our customers, because the code I reason about today, the code we mentioned today, part of background services, it's residing on particular devices of our visitors, users, customers. Cool. If we have sort of diagram, and it's not a secret at all that pretty much all the code we have as a part of background services is residing in service worker, which is programmable network proxy in the logical chart. So we have service worker in the center of everything in that sense. And it can receive events from our application itself, explicit ones or implicit ones. Just an example here is fetch event. When you try to reach out to some resource from your application, when you try, I don't know, to send a request to your API explicitly, or if you have implicit HTTP requests as a part of your HTML markup. For example, when you try to download your beautiful logotype, which is part of EMG tag, all these events are catchable in service worker. Next level, we have browser, which also can send events to service worker, depending on some interesting things happening under the hood. For example, when we download larger resources, it's a good sample. Next, operating system. Of course, it all proxied via the browser, but for example, checking the status online, offline, I believe it goes from like internals of operating system, and this event proxied by the browser also goes to service worker. And of course, all outer world, let's just have this cloud internet here, can also send events to the service worker. How can we react on all this variety of events from very different sources? In a very, very different ways. First, if the tab with application is open, we can easily organize bi-directional channel to communicate between our service worker and app if needed. In case when application tab is not open, or maybe even visible part of the browser is not open, we can easily launch the browser and open corresponding tab with the application, and again, maybe to organize bi-directional channel. So it's a quite powerful feature. Or maybe we don't want to launch the full application. Maybe all we need is to just show the notification, which is native one, part of the browser UI, or many operating systems, they include these browser notifications as a part of their notification centers. For example, on Windows 10, you have these browser notifications as a native part of operating system now. Or even more exciting thing here, we can run completely custom code we as developers write, completely transparent for the user, I mean invisible, without showing notification, without launching the app. Maybe this is most exciting, maybe most dangerous feature. Let's dedicate a couple of slides to this a bit later. Good, so now we know everything about the events. Let's go back to the background services, which are event-driven ones. How can we get the list of these services available in the particular browser? In every Chromium-based browser, it's super simple. You just open developer tools, you just open application tab of developer tools, and somewhere on the left-hand side in the bottom, you will see the list like this. I believe it's appeared maybe in Chromium version 80, and let's say this list is constantly evolving and growing. This is a current snapshot. And of course, like everything in DevTools, it plays a significant role in helping us to test, debug the application. Of course, this list is not to list the services, right? So if you click particular item here, on the right-hand side, you will see a table with the list of events you received for this particular API, which helps a lot to debug this. To be honest, I don't even remember how we as developers survived without this feature. And furthermore, you can hit record button and you will have all the events recorded for you, logged for you for, I believe, maximum 3 days, which is more than enough for testing. Okay, let's go through some of, let's go through all of these services. Some of them will take very briefly. Some of them will have a bit more detailed deep dive. Payment handler. This is quite unique API in terms of service worker installation. This is maybe the only API of the service worker family which allows developers to install service workers on the fly, just in time. This is correct term. What's the consequence of this? You can get your your customers can get service worker installed on their devices without them visiting your origin, your host. It's a bit scary, but there are lots of considerations, rules, limitations, so it's quite safe to use. And where do you use it for? It's for quite a niche scenario when you develop a payment provider based on web. So this is for the companies which are going to build their, let's say, payment service, which is fully based on web. So yeah, since this is quite unique use case, let's skip a detailed explanation of what is this. Background sync API. This is our best helper when we need to get one simple event. When we, not we, but our users go from offline state to online state. How the browser or operating system decides when this moment comes, we don't care. So we outsource this exploration to the browser, to underlying operating system. We as developers are just interested in one particular event. We just want to understand when our users go back to online. Why? In the most examples, in most use cases, I've seen that you mainly want to reproduce the network requests you, not you, but your user did while they were offline. It's a great helper for us to provide proper offline experience when, for example, we want to create I don't know, a web blogging application where you can write down your post and hit send, and you don't have to care about your connection status. So when you hit send and you are suddenly offline, you will not see server not found. You will see something like your post will be delivered when you go back to online. But please be aware that there is no magic here. So this API will not help you to provide all this user experience, will not help you to save the data your user wanted to send. It will not help you to show the message. No, we as developers are fully responsible for this. The only signal we have from this API is this particular event in service worker. But it's super powerful because the time when this event comes, we don't care about the status of tab with the app. So user could close the application, could close the browser if they have setting to continue run the browser in background, and that's it. All the magic will happen under the hood, if we call this. Next one, background fetch. It's very interesting one. So on the one hand, it's about detaching. We want to detach the process of downloading or uploading data from the lifetime of the application. What do I mean? Compared to the regular fetch, we don't care about the status of our main application. So just imagine if it's a regular fetch, you click, I don't know, download something, and you close your application tab, and your download is gone. So this fetch will be canceled. In that case, this download will be continuing, and nothing bad will happen. User will see the UI that something is downloading, and they can pause this download or continue this download. So the UI is looking like exactly the regular browser download when, for example, you just link, for example, MP3 file with regular Anchor tag. You will see exactly the same UI with a very serious difference. If you provide the download of some resources using this A tag Anchor, once it's downloaded, this file, this resource is becoming part of operating system, right? So your application, your JavaScript code knows nothing about these bytes you downloaded. In background fetch, we attach the data we downloaded to our application. I mean, the bytes we downloaded are available in our service worker, and again, we decide what to do with them. For example, we can put them into cache storage and use them later. This way we can easily organize completely web front-end based podcast application or videocast application when you want to give possibility to the users to pre-download some episodes. So it's nice addition to web family. Push messaging. It's actually not only about showing the notification. So we as developers have to keep in mind that on push event, we can basically run any code in our service worker. And of course, we have to comply with the lifetime limit of the service worker, which is some seconds and different from browser to browser, maybe from version to version. Basically, we have only one limitation here. We have to show the notification. So despite we can send the signals from our backend to thousands, if not millions of users' devices, of people who explicitly agreed to receive notification from us, but we cannot do it invisibly for these users, because if we, for example, forget to call this show notification method of notification API, the browser will show something for us with some generic message. So users are always aware that something happened, and they will see the origin, they will see the browser, so they know where to go, and maybe they want to disable the notification if that looks incorrect. So what's left? Notifications and periodic background sync. Notifications API, this is best friend of push messaging. Basically, as we discovered 5 seconds ago, there is no reason to use web push API without notification API. It will be just wrong flow. But notification API is self-standing API, and we can ask users permission to show notifications and show the notifications themselves completely without any interaction with service worker. So it's available for basically any application, right? Not only for PWAs. But in that context, we will continue our discussion about more specific part of notifications, which is notification triggers API. And both notification triggers API and periodic background sync, for the simplicity, I will call this PBS sometimes, are somehow time-based activities. And maybe this is the only fact that is common for these two APIs. Other than that, they are very different. And to better introduce these two, I have this table of differences of PBS and notification triggers. Let's start. Timing. Even from the name of periodic background sync API, we can clearly understand that it's something about intervals, about periods, right? And once we registered this, let's call this sync, it will stay for more or less forever with this application on this particular user device until we explicitly unregister this, or maybe until the user will completely reinstall the browser. On the other hand, notification triggers is one-time thingy. So once notification shown, gone, and plus we specify exact time for this. Okay, what we can do in PBS? Pretty much anything. We write the code ourselves, so we decide what to do on particular intervals on this user device. Notification triggers, from the name of this API, it's quite clear that it's only about showing the notification, at least for the simplest scenario, without any kind of user interaction. Next, what can our user see? In case of PBS, it's completely invisible. So what we do under the hood is for us. So for the user in majority of scenarios, and maybe by design, it's completely invisible. Notification triggers, well, again, notification. This is the nature of this API. And by notification here, and on previous line, of course, I mean the native notification of the browsers, not something that we built ourselves using our beautiful UI framework. No, it's about native one. If we look at these three items for PBS, just imagine, we register it only once, and it runs forever. We can run completely custom code, anything we want, mine Bitcoins, welcome, and user will not get any notification, any updates about this. It sounds really scary, right? And of course, all privacy, security, resource consumption consideration has to be taken into account. This is why the final decision on sending or not this event and how often to send this event is up to the user agent, which is browser, right? In case of PBS. So browser tries to do its best to predict, is this something that user really need, really want? Good luck. With notification API and notification triggers API, there is no such a strict limitation. This is why I mentioned that we as developers are deciding show or not show the notification and when to show this. Let's go next. Maybe only point where notification triggers API is more powerful than PBS is connection status. The main power of notification triggers, of course, it's for offline usage, right? Because online, we somehow can mimic this API by regular web push, by sending signal from our backend. But when users are offline and you still want to show something, for example, user can have some calendar reminder, or you can build a web-based alarm clock application, right? Then PBS is only making sense while users are online. This is, again, nature of this API. It's by design. And after all, what required from the user side to make these apps, these APIs running? It's quite a serious limitation for PBS. You have to have your web application explicitly installed on user machine. Let's say this is not part of the specification or explicit part of the specification. This is, let's say, a browser's decision. And in Chrome, it works like this. You have to install your web app in order to have PBS running. Luckily, these days, thanks to web app manifest specification, it's quite easy to do, right? And it's user's decision to have this application as a part of home screen or desktop. Plus, you have to give explicit permission to run this API. Notification triggers API, regular notification permission. So, for example, if your users gave permission earlier to receive push notifications, then you have this permission for your origin, and notification triggers API will work. And you can always send the request about this permission again. Good. Now it's time to have a look at the code. And the code will be very, very simplified, just to give you an idea how that works. Periodic background sync. We always start with the feature detection. So it should be your habit when you are working with APIs from service worker family and more general APIs from PWA concept. So please don't forget about this. So once we checked that this is available in this particular use case, you just register this sync. You might want to give a name because you can have multiple syncs for one application. So in that scenario, I call this one update content. And you provide basically one parameter called minimal interval, min interval. And by saying this, we ask browser to send this periodic sync event not more often than one day in that case. Okay, and on service worker side, we catch this event called periodic background sync. If the tag is the one we want, we can run pretty much any code in wait until method. And here I have this imaginary update content. For example, we can prefetch list of the news or list of the tweets if we build a web-based Twitter application. Anything we want to keep the data fresh, or maybe you want to update the application application shell itself to keep your application version fresh. And then on, for example, next run, your user will be delighted by completely new content or next version of your application, again, without doing anything explicitly and without waiting for this. But you see my comment. I encourage you, think before you sync. What do I mean here? Browser, as we remember, does its best to prevent this API from overuse or misuse. This is why it applies so many different limitations. But we as developers can do step forward and to implement even more careful logic about the user. For example, maybe we want to fetch this new data or new version of the application only while the users are on Wi-Fi. Maybe we don't want to use their cellular traffic, right? Or maybe our user is in data saver mode, and then most likely, definitely, we have to just cancel everything, right? Because our user explicitly asked, please, 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 I don't want to overuse my my traffic on this subscription. And after all, if we are about to download some bulky data, maybe there is not enough space on the user device, or like this space is limited. We have API to check for this. So it's really best practice to do extra checks. So browser is caring about the user, and we have to do so. Okay, about the timing. Are we talking about seconds or hours or days? This is the table I found somewhere on GitHub to give you a bit more details on particular implementation of periodic background sync in Chrome. And you see here that in best case scenario, it's about 12 hours. So these periodic syncs are definitely not about some real-time data. No reason to build your, I don't know, Exchange ticker application with thinking about PBS. No. By default, we have 36 hours, and then it's like gradation. What it depends on? It depends on artificial index called engagement score, which is calculated by the browser for this particular browser on this particular device. And basically, it's about how often and how long the user is interacting with your application. Let's say if they open your app from their home screen every hour, most likely your engagement score is very high, and you will get this best case scenario number, which is 12 hours. Why is it done this, let's say, cumbersome way? To care about resources, because just imagine user register dozens of first user install dozens of web apps, then these apps have periodic background syncs API enabled, and just imagine if every application will do something, even every 12 hours, completely invisible for the user. So it's consumption of CPU, memory, traffic. After all, it's easy to get user very sad about this API in general, right? And then this API will just be deprecated because no adoption, users are unhappy, developers are unhappy. So it's about finding the balance. If the application is popular for this particular user on this particular machine, it will get 12 hours. If not, maybe with some period of time, this API will just stop working. Okay, let's jump to the notification triggers. It's completely different, but still time-based. Again, it all starts with the feature detection check, and here you see example of regular native web notification for Windows 10 for Microsoft Edge, if it's not a part of Windows Notification Center. So you have this possibility to attach or detach this message. Okay, then we have the possibility to specify exact time. So in this sample, I just say, hey, browser, please show the notification 5 seconds from exactly this moment, and right after you registered this trigger, you safely can close the application tab. You can safely close the browser if it resides in memory, and this notification will show up. And of course, you can safely turn off your Wi-Fi. This is the power of this API. And also, the way we specify trigger gives me hope that with time we might get other triggers, not only time-based ones. For example, geolocation trigger. So you might be able to set up some notifications for the users when they, for example, go out of from some particular area on the map. But it's for the future days. Okay, then let's go back to this slide. It's actually interesting because for this API you have to have service worker registered, but in the simplest case scenario you don't write any code in service worker itself. If you just want to show the notification and you don't care so much about user actions on this notification, it's basically all code you need, but you still need service worker to be registered. How to still use power of the service worker? For this case, I came up with a slightly artificial, slightly synthetic use case when we try to mimic the behavior of periodic background sync using notification trigger API. So it's a bit crazy scenario with many considerations, but still, let's try to do this. So what do we do here? First, for notification trigger API, you can also provide tag, quite similar to what you do in PBS. Okay, let's have update content tag, and then we use power of service worker. Because for these notifications, like for generic web notifications, we have all the events after user interaction available in our service worker. For example, notification click, notification close. So let's just pretend that we asked user, do you want to update your application or data of your application? And if user click yes, then we basically run the same function, update content, and launch app. I call this very long and explicitly. And this way, somehow we mimic behavior of PBS. Of course, the downside of this is when user click this notification, we might be offline, and then well, no reason to ever try to do this update, right? And at the same time, for example, in the same method, we can schedule the next request to update your application. So this is just one of use cases where we can use power of service worker in connection with notification triggers API. Okay, let's talk a bit about availability of these APIs in different browsers. First, I have long answer for you. It really depends on many things. Mobile versus desktop, which browser, which version of the browser, which settings, maybe which flags, and also part of API could be in origin trial mode, and then it depends on particular origin. Plus, you remember that PBAs depends on install state. So many things to care about, and if you wish to get detailed information about what's available where, these resources I listed will help you. But if I have long answer, I have to have short one, right? And I have it for you. It's called PWA. What do I mean here? Just remember that P in Progressive Web Apps acronym is about progressive, and it means nothing but progressive enhancement idea. So just do feature detection, and do not rely on this API in terms of critical pieces of your application. I mean, do not build your business logic around these APIs. Always think about all this great stuff, like about something cool that you might add on top of your core functionality. And it will simplify your life a lot. Let's sum up. The goal of APIs related to background services and all APIs from service worker families and even more general APIs of PWA concept is to catch up with what native code can do and maybe even overtake this. If you go into details of PBS implementation, you'll find that it's even more flexible and even more powerful compared to what, for example, you can achieve by using native for example, iOS or Android APIs. Next, we have to be very careful about what we deliver to the user versus what we require from the user. What do I mean by requirements is two things. First, all these multiple requests from our code, which might be very annoying, like allow notifications, allow PBS, allow something else. It's not the best experience. Plus, we consume resources, right? Again, if we are talking about PBS, if we misuse this API, we just use CPU power, memory, and network bandwidth for nothing. From the developer perspective, all these APIs are based on web standards, so it's regardless of the status of implementation of this or that in particular browser, it's not proprietary APIs related by one vendor. It went through all these processes of all web APIs, like RFC with community, draft stage, that stage, so it follows all these steps. Tooling-wise, it's a pleasure to debug everything, again, using dev tools. And what I love the most, this is just the beginning of great journey of the web, and you can check tracker, it's public tracker of Fugu API by developers of Chromium. There are more than 100 APIs like this to achieve the equality what we can do with web and with native code. If you are impressed by these features and you want to continue the discussion about PWA, service worker, background services, join PWA Slack. This is the largest place on planet for at the moment, with more than 2,000 people discussing this stuff, including folks from browsers, libraries, and frameworks. And on that, thank you very much. I'm open for your question, folks.
You can go to Q&A Q&A part. So let's some question. If you click on it.
Okay.
Yes. Chat, participant, and Q&A.
Okay, got it. Let me put it here. And maybe let me. Okay. Question number 1. On Android, when you run a routine on the main thread that takes too much time, you get an alert from the system to run it on new thread. Is it possible to get similar alerts from browser? Good one. And the answer is, I don't know. I believe it's not directly related to service worker. It might be more related to what more general APIs web workers does, but I haven't heard about anything like this. I never seen any notifications or requests from the browser. So I believe the answer is no, nothing at least visible to the user. What I know that lifetime of the service worker is limited, and don't even try to run any long-running process in your service worker, because it will be just killed by the browser. Exact number of seconds to run service worker is different from browser to browser. But anyway, think about everything you run in service worker, including background services, like about quite short event. Of course, it's different when we are talking about background fetch, which is designed to run long operations, but it's different use case because user is aware of something has happened because the users are seeing the UI of the downloads. But other than that, service worker lifetime is limited. But I'm not sure that there is some limitation on resources consumption. Next question about Workbox. Workbox, I'm so happy that you mentioned this. It's my favorite work tool related to all things PWA. From the APIs we went through today, you will get great help on background sync. And I believe it's the only API for now from today's list. Workbox is a modular library, so please feel free to contribute next modules. Maybe I inspired you to create a module for Workbox, which is, for example, abstracts the work with background fetch, and you will simplify the life for the developers. And to elaborate a bit on Workbox with background sync, if in completely custom implementation of, for example, repeating of failed requests, you have to care about many things. First, you have to care about saving the data, right? And most likely you have to use IndexedDB for this scenario, which is generic storage for your web browser. And the API of IndexedDB is not very pleasant to work with, I can say like this. Then you have to organize sort of queue, for example, to send more than one failed request. For example, I'm typing my tweets in my web-based Twitter client while I'm offline like crazy. I post 1, 2, 3. You have to preserve everything, and then on sync event you have to iterate through this queue and send it by one and check the status, because this request might fail again for some reason. What Workbox does, it abstracts all this complexity. It just says, okay, dear developer, specify this URL, specify this HTTP method, for example, API/post tweet, and the method is post, and we will do the rest for you. All failed requests done against this API using this method will be automatically repeated for you. It somehow limits our fantasy on how to use this API, but on the other hand, it does its main job with great success. Plus, it even has a fallback for the browsers without background sync enabled. Okay, the next one about Safari. Oh, I expected lots of questions about Safari, WebKit, Apple. What did you think about last announcement of Apple to not implement some APIs? Yes. There is some hype on Twitter these days related to the article from WebKit folks about they decided to not implement 16 APIs from Web APIs family. So not all of them, maybe neither of them are directly related to PWA. Let's say they are all related to web capabilities, and the majority of them are about hardware capabilities like Web NFC, Web USB, and all this stuff. So TLDR, they decided to not implement these APIs at all because they might somehow help to the bad actors or advertisement actors to do fingerprinting or to send some, let's say, anchors on user's device for to profile users to know something about them. Let's say to reduce privacy. I cannot say that I'm super happy about this, and of course there is some bias because Apple successfully implemented lots of other hardware related APIs. So again, I'm not happy about this, but on the same article there is a notice right under the list of these APIs saying something like, when we decide that ability to fingerprint using these APIs is reducing, we might reconsider implementing these APIs. So let's say this is not their final decision. This is their just current decision. But of course, it doesn't contribute well to the web capabilities. Okay, next question. Safari again. Is there any workaround we can use to do background fetch or background sync? Let's start from background fetch. From some internal discussions I've seen as meeting notes of some gatherings of standard committees, I've seen, I might be wrong, but at least this is something stays in my mind, that folks from WebKit most likely will implement APIs which expose something visible to the users. And the background fetch in that sense is a good candidate because it's not something that happens completely under the hood, completely invisible. By its nature, users see this downloading UI. So I don't have any signals from Apple, from WebKit about implementing this particular API, but let's say it's a good candidate. It's a good candidate, and I believe that sooner or later this will land. Background sync is a bit more challenging in the sense that it invokes service worker when let's say users are not aware of this. So maybe this is something that will be delayed with implementation, or again, I don't have any signals about this. About workaround for background sync, check workbox. Of course, it has quite a serious limitation in terms of you have to have your tabless application running, but other than that, I believe that should work in Safari also. Okay, next one. What kind of use cases do you imagine good usage for PBS? News application, any social media application when you intended to download the fresh feed of some posts. So these are the best candidates. So the scenario is every particular interval of time, your application is fetching the data, if that's possible to do online, and then users open your app and immediately see the fresh data. This is something that we never had on the web before. And by the way, I forgot to mention one more serious limitation of PBS is it works only on the network where it was originally registered. I mean, if your user registered this PBS synchronization on their home Wi-Fi, this synchronization will happen only on their home Wi-Fi. Again, it's not super cool for us developers, right? It doesn't simplify our life, but it's cool for privacy. So it doesn't leak user IP, at least. Okay, next, about mean interval. Is there minimum forced by browser, or we can set one? I'm not aware of any restrictions from the browser side here. So, but maybe a good idea for me to check the specification. Next, could we do something as force Apple? Yes, we can. Yes, we can. WebKit bug tracker is open. At least it has some public parts. So just go there and ask folks from WebKit, and maybe this is the only way. But main problem I see with WebKit is they do not disclose their plans, their roadmap. So in many cases, we as developers can get information from them once a year, right? And plus some technical articles about next versions of Safari. But again, it all happens after the fact they released something in beta version. So we don't have anything similar to, for example, Project Fugu tracker. So we are not aware of what they plan. I hope this will change, because recently, and I tweeted about this, they hired really great folks to their developer relations team, and I expect they will be way more vocal with the developer community. And I hope this will be bi-directional channel, so they will not only say but also listen to the feedback. Okay, with periodic background sync, we can run every kind of code. Is there any timeout or thread block mechanism? Any code, yes, any code that is available to run in service worker, and in service worker, not related to PBS, but in service workers in general. For example, we cannot use synchronous APIs like local storage, like session storage. But we can use cache storage and IndexedDB instead of this. We cannot use XML HTTP request, but we can use fetch instead of this. So let's say regular service worker limitations, regular limitation of service worker lifetime. We had a short discussion about this earlier today. Thread block mechanism, I'm not aware of this. So that means that I don't know if you, run infinite loop in this piece of code, will something happen or not? Most likely, your service worker will be just killed after its timeout. I'm not aware of any other limitations. Okay, I'm not sure the difference between background fetch and background sync. Yes, sure, my pleasure to elaborate. Background fetch is about downloading and uploading of large resources. And basically, it's a helper for the developers to build web front-end applications which can download large resources, download them again, detached from the application tab life cycle, and keep this data in cache storage, which is available for our JavaScript code. So it's, let's say, it takes best parts from regular fetch and from regular download you use using Anchor tag. On the other hand, background sync is a signal sent to the service worker when user goes from offline to online state. As simple as that. How do you use this signal? Completely up to you. In most scenarios I've seen, it's just a repeat of failed requests. So most likely you tried to post some data while you were offline, or not you, but your user, and you have a chance, you have a second chance to do this. So these APIs are quite different. So they only have background in their name as something similar. Okay, next one. I can't remember what kind of service I was using, but my PWA pages were refreshed while user was using the app. Very bad user experience. What service should we use to update our application? I believe you used the classical combo of fetch plus install plus activate events. This is quite a common scenario to pre-cache and to maintain versions of your application shell, which is actually your application minus all the data it consumes during runtime. And yeah, you're absolutely right. There is no silver bullet for this. How does it work? On the very first start of the application, you ask service worker to explicitly cache everything you downloaded, your index.html, your main JavaScript bundle, your main CSS bundle, maybe your beautiful logotype. So it's pre-cached. On the next application start or even next refresh, the browser is not taking these resources from the network. It takes these resources straight from the cache, from the very special type of storage called cache storage, which is nothing to do with HTTP cache. So this cache storage is available for us to use straight from JavaScript code. So this is the magic of all offline web experience. So and of course, thanks to this flow, your application works when you are disconnected. On the other hand, it brings inconvenience while we are updating the version of our application. Just imagine we uploaded completely new logotype. We fixed some errors in our JavaScript code, and our dear user, they open their application next time. What will they see right ahead, straight now, in a millisecond, without even going to network? Right, your previous version, which was pre-cached. And only after this, you can write logic in your service worker or ask Workbox to do this for you, to fetch updated version of your application. And the next refresh, your user will see your new logotype, right? So this is a well-known trade-off. How to deal with this? Multiple options. Maybe the one you are talking about is explicitly refreshing your application right after a new version was downloaded. I completely agree. This is awful user experience. Please don't implement it like this. You can do this in your service worker, but if you really wish to notify your user about new version is available, just show any maybe unobtrusive pop-up somewhere using your UI framework that new version is here and you might want to refresh. I bet you've seen dialogues like this. That means that this website is driven by service worker and you have offline version and something was changed on the server in between this and your previous visit. So this is scenario number one. Scenario number two, use PBS. And of course, with all its limitation, it allows you to do this update in the background while user is sleeping. And next time they open your application, they just see a new version, and as simple as that. Basically, it's not invented by the web. This is how all modern applications on iOS and Android work, right? So we are used to this experience in native code. Now it's possible to do on the web. And the next one, finally, did Safari will kill the data of service worker cache if the app is not installed in the home screen? I believe yes. I haven't heard about any changes related to this decision. If I remember correctly, they give sort of 1 or 2 weeks lifespan of the data, and it's not only about service workers, it's about pretty much all data your web application somehow pre-cached on your iOS device. Service worker, cache storage, IndexedDB, everything. Again, maybe not super friendly to the developers, but super friendly to the users. Maybe if you do not use your application that often, maybe you are not interested in this at all. Maybe there is no reason to keep these bytes on the user device. But it doesn't applicable for the scenario when you use this app often. Let's say next time user opens the application, this counter will be start from 0. So it's not like hard limit. No, it's about only, let's say, non-popular by this particular user application, which maybe makes sense. How to live with this as a developer? The same, progressive enhancement. You don't normally rely on service workers, right? It's something, some icing on top of the cake, right? It might improve user experience, but again, if you build your business logic that service worker has to be there and this API has to be there, most likely you have a problem with your architecture. Just rethink. Okay, it was the last question in my list.
I think we've done, indeed. So thank you, Maxim.
You're welcome. It's my pleasure. I don't remember so many questions after my session, so I'm super impressed. I got so big pleasure.
Okay, so if you are too shy to ask questions now to Maxim, we can turn off the present mode and switch again into maybe 5 minutes again in the network mode. And if you want to, you can talk with Maxim again. So thank you, Maxim, for your presentation. It was very interesting. I discovered some events.
Great community, great event.